Hi, everybody. So I've got a couple questions on your case study, and I reviewed the questions and finally understood what people were talking about. I thought I'd do a quick overview of question 11, part B. In order for me to get to part B, I kind of have to go through part A, so this will be a bit of a refresher. So if you look in your case study, you'll notice that it says for question 11, 96% of Florida panther population has a normal tail. 4% of the Florida panther population has the crook in the tail. And then the two questions are A, find the dominant allele frequency and the recessive allele frequency, and then B, construct a genetic cross that would illustrate the phenotypic outcomes of the results listed in part A above, including a Punnett Square illustrating the cross. Include a key or legend describing the pattern of inheritance for the trait, the genotypes of the parents, and the phenotypic percentages of the cross. And so to get you started on this, essentially, the very first thing that we have to ask ourselves is, how do we figure out the dominant allele frequency and the recessive allele frequency? Well, since we're doing tail, I'm going to have that T equals the dominant, big T, and little t equals the recessive. And then from there, we need to find it. So we know that 96% of the population has a normal tail. So with that being said, 96% is going to be a normal tail. And so what do we know that that will look like? Well, if you go to the next part, it says 44% has the crook in their tail. Well, if you look right before, it says the tail crook on the right, seen in Florida panthers, is believed to be the result of inbreeding among the population. Assuming that the pattern of inheritance is autosomal recessive, calculate the following using the Hardy-Weinberg equation. So from the little paragraph that's right before this question, it tells you to assume that the one with a crook in it is autosomal recessive. So this is going to be little t, which means that 96% of the population has the dominant phenotype. Now, with that being said, it could be that it is big T, or big T, little t, right? We don't know which one it is. And so the very first thing we have to do here is we have to be able to look at and figure out what the dominant allele and recessive allele is. We can do that by using this, because we know that little t is written in the Hardy-Weinberg equation as q squared. And so we do that q squared equals, now we have to convert this from 4% to a decimal. So you can divide that by 100 and it's going to give you 0.04. Now, if we want to find how the allele, well, the two alleles we have are the big T or the little t, which the big T in Hardy-Weinberg is P and the little t is Q. So to find Q, we have to square root each side. So Q equals 0.2. Now, if we want to get that in a frequency or percentage, we multiply it by 100, because that's what we look at, 100% of the population, and we're going to get that it's 20%. Now, then we can go and use this, the Q, to find out using the allele equation of Hardy-Weinberg, which is P plus Q equals 1, what P is. And so you just put for Q 0.2 plus P equals 1, and then you subtract 0.2 from both sides, which gives us P equals 0.8, or 80%. So this gives us both what P and Q is in decimals and in percentages. Now, you will probably be used to using either, when we look, a Punnett square that looks like this, where if we were talking about P's and Q's here, right, we'd have an allele here and say the other allele here. We're going to use P and Q. And P and Q here, right? And so this gives us a total of 4. And this would get just a simple cross for a single generation. But if we're wanting to look at it in terms of a gene pool, something much larger, then we need to figure out a way to do this to incorporate percentages. And so you can take this, and we're going to go, and instead of doing our normal, because this is saying that 50% of our alleles are P and 50% are Q, going this way, right? And this is saying 50% are P here and 50% are Q here. So everything's basically 50%. So if we want to get a closer to the percentages, we can add and do 10 to incorporate 100, which is what we have our percentages in up here. So we have 1, 2, 3, 4, and 5, and then we have 1, 2, 3, 4, and 5. So across the top, we have 10. We can do the same thing on the side. We have 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So now we have 10 down the side. So we have 100. So if we're looking and we want to figure out, okay, we have 4% of our population is TT. We can go and we can ask ourselves a couple ways. We can check this because only 4 of the boxes should be aligned if we do this correctly. Now across the top, if you see where we have P and Q here, well, we're going to look and we're going to figure out across the top, what's the percentage or how many of these boxes should be P versus Q. Well, we know our Q is 20% and our P is 80. So if we have 10, that means that 2 of them are going to be Q and the rest of them will be P. So you can draw that line all the way down. Now, if we're looking at the other side, it's similar, right? So we'd have 2 that are Q, and the rest are P. So this is what our Punnett square would look like if we are essentially looking to create and use our allele frequencies. And so then you can check, how many do we have? 1, 2, 3, 4. Or we have 2 times 2 is 4. So this is 4%. That is Q square or TT. Now here, if you look, these, if you go across, this is down is Q, right? Across is P. So here we're going to have a P and a Q. And so you can count 1, 2, 3, 4, 5, 6, 7, 8 of them are incorporated in this. And then you have 2 across. So 8 times 2. So you have 16 that are going to be PQ. Now, if you look here, this is another group that have come together that are the heterozygous, and it's the same. It should be the same. 1, 2, 3, 4, 5, 6, 7, 8, and then 2 down. So 8 times 2 equals 16. So this, you have 16QP. And when you write this together, the P is the dominant, so it always goes together, right? And then here you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 64 that are PP. And so then you can look at this and figure out essentially that you have 64% that are going to be the homozygous dominant. 16 plus 16 is 32% that are going to be the big T, little t. Now you can add these together, 4, 5, 6, 6, 7, 8, 9. So you have 96% that are the two together. And then essentially you have your 4% that's there. So this is how you would go about figuring out essentially what you have to do the cross, and to give you an idea of what the entire gene pool would look like. I hope this helps. If you have any questions, please let me know.